Imagine a law of nature that says you can never know everything about something at the same time. For nearly a century, physicists have treated this as unbreakable. Heisenberg's uncertainty principle. It's a cornerstone of quantum mechanics. If you know a particle's position precisely, you lose track of its momentum, and vice versa. Think of it like photographing a speeding bullet. Freeze its position and you blur its motion. Track its path, and its position becomes a streak. This isn't just a technical limit. It's built into reality itself, setting a hard boundary for measurement. For scientists, this quantum fuzziness has been a frustrating barrier, capping the precision of our most sensitive devices. But now, researchers from Australia and the UK have found a loophole. Not by breaking the rule, but by cleverly redistributing the uncertainty. Instead of eliminating fuzziness, they shifted it into properties they didn't care about, making the measurement they wanted incredibly sharp. It's like negotiating with nature. You can't erase uncertainty, but you can move it out of your way. This breakthrough lets us measure one property with unprecedented precision while letting another become blurrier. The uncertainty principle still stands, but we've learned how to work around its limits. It's a profound shift, not breaking the rules, but understanding them so deeply that we can bend them to our advantage. The door to ultra-precise measurement is now open, and it all started with a simple question. What if the universe's hardest limits aren't as hard as we thought? So how do you move uncertainty? Picture squeezing a balloon. Press one side, and the air bulges elsewhere. The total stays the same, but you control where it goes. That's the principle behind quantum squeezing. Scientists squeeze uncertainty out of the property they want to measure, forcing it into another they don't need. Imagine a clock. If you only care about the seconds, you can make your measurement of the second hand razor sharp, while letting the hour hand become a blur. In quantum physics, this means preparing a system so that uncertainty is concentrated away from the measurement of interest. The total fuzziness, as Heisenberg dictated, never changes, but you choose how it's distributed. Normally, uncertainty is spread evenly like a round balloon. Squeezing creates a lopsided balloon, thin where you want precision, fat where you don't. This is the loophole. By squeezing, researchers can measure changes far smaller than the standard quantum limit. They didn't break the law, they just reshaped the playing field. Squeezing is now a powerful tool, letting us see details once lost in quantum noise. It's a cosmic bargain: trade uncertainty in one place for clarity in another. The result? Measurements once thought impossible are now within reach. Sometimes the deepest breakthroughs come not from breaking the rules, but from learning how to bend them. And that's exactly what these scientists have done. The experiment sounds like science fiction. At the University of Sydney, physicists trapped a single ion, a lone atom, suspended by electric and magnetic fields. Using lasers, they made this atom vibrate, then prepared it in a special grid state, a quantum checkerboard where the atom exists in multiple locations at once. Originally designed for quantum computing, this grid state became a quantum ruler. Its fine pattern made even the tiniest shifts obvious. When a minuscule force nudged the atom, the entire grid shifted, making the movement detectable far beyond the standard quantum limit. By squeezing uncertainty into unmeasured properties, they achieved astonishing clarity in measuring the atom's motion. This was the first time such exotic quantum states were used for sensing, not just computing. The result, ultra-precise detection of weak electric fields and tiny movements, previously lost in quantum fuzz. It's a stunning example of scientific creativity, turning a tool for one field into a breakthrough for another. This isn't just a lab trick. It could transform technology in our daily lives. Quantum-enhanced sensors could revolutionize navigation, medicine, and even our understanding of the universe. Imagine navigation devices that don't need GPS, submarines navigating for months underwater, or your phone knowing its location deep underground. In medicine, more sensitive detectors could make MRI scans clearer and safer, or spot diseases at the cellular level before symptoms appear. For astronomy, squeezing quantum uncertainty could make gravitational wave detectors thousands of times more sensitive, letting us hear whispers from the dawn of the universe. The impact: earlier diagnoses, safer procedures, and new windows into the cosmos. This breakthrough turns a fundamental quantum limit into a powerful tool. It's about making the impossible possible across science, technology, and everyday life. The ripple effects could touch everything from smartphones to space exploration. The future of precision starts here. For a century, the uncertainty principle was a wall. Now we see it's a door if you know how to open it. This discovery is still in the lab, but the path to real-world devices is clear. Like the laser or transistor, it could spark a technological revolution. Mastering quantum uncertainty could unlock advances in computing, secure communication, and fields we haven't imagined yet. Are we at the dawn of a new quantum era? The signs are promising. By learning to bend the rules, we're gaining new clarity about our universe. The quantum fuzziness that once limited us is becoming a resource to shape and control. The future isn't just uncertain, it's full of possibility.